So it's still just about morning, so good morning-ish. My name is Laura. You may remember me from such talks on Wednesday as bootstrapping security. If you were not in that room, you missed out and you should feel really bad. And as penance, you can go and watch the video afterwards. So that'll be fun. Think of it as homework before you've even begun. We're here today to talk about buzzwords and security. Today's buzzword, microservices. Don't be offended, though. I like to play around with the fact that we kind of keep catching new technologies. To the people sat over the far side, you seem lovely. Hi. Hello. I'm still going to look at you and point you out. If you want to join the rest of us, you're more than welcome, but please stay where you are if you're comfortable. Right. So let's get started. This slide is as much for the viewers at home who are going to watch the video as it is for you. Please note that almost everything in our space, as you should know as engineers, moves relatively quickly. And as such, a nice talk that I do today in 6 months might have advice that doesn't make sense anymore. So whenever you come into a talk like this, always remember that this is only really good for this moment in time, and always go and have a look up and check if guidance has changed before putting this into your production environments and going YOLO. So I run a small company. It's very small. We're 5 people. We're based out of Auckland, across the way. We bring security into very fast-paced life cycles, and we do that in 6 countries with 32 clients. But I'm not here to sell what I do there. I'm here because this is my window in my office. I spend as much time cutting code, sadly, and my team would rather I stop, than I do advisory and teaching and training and speaking. So a lot of what I'm talking about today isn't from some nice, beautiful textbook that will, bestow the world of knowledge. It's because I've screwed this up. It's because I see this every day, deep down dirty in code. Now, I know most of you are .NET developers. Please forgive me, I'm a Python developer. And before that, I was a PHP developer. Before that, I did Java. And before that, I did COBOL, which is basically the worst family tree of skills you can have as a developer. So this is my Kanban board. It's a window. It's Post-it notes. It's for an open source project that I write. And this is me. I write bad code. I help other people write code that sucks less than mine, hopefully. In today's talk, we have a lot to cover, and it's going to come with a couple of caveats. Firstly, I'm not a massive fan of the code on screen demos. I can open a terminal, I can type some green letters and hit enter with a flourish, and you will all feel satisfied that I am therefore technically qualified to speak to you today. But I'm not going to waste your time. There's going to be a few tools and things I mention that you can go away and play with, but they're really well documented. There are good tutorials out there, and the slides have links in them. So if you follow me on the Twitter, which is lady_nerd, you can get those links and you can have a play. So please don't judge me on my lack of demos. I just don't think it's a good use of our time at this point. We've too much to cover. And this is what we're going to get through. We're going to talk about a couple of security fundamentals, because for some of you, you've actually not spent most of your life in the dark places on the internet. So there's a few things we have to remember. We're going to look at some prevention techniques in microservice architectures. So how do we stay safe? How do we stop people from attacking us or make it harder to attack? And then we're going to look at detection and survival, because the sad thing about security is that it's almost guaranteed eventually you will get compromised. That's going to happen. Now, that's sad. Makes everyone sad, makes me sad. But if we're prepared to survive, it doesn't have to be the end of our companies and the end of our tools. It is just another day. It's another issue, much like a scaling problem is an issue, and that mistaken deployment to production that kind of makes everything cry is a bit of an issue. We can get past these things. So let's start with some fundamentals. Now, things I'm not going to do in this talk. We literally have Sam Newman in this conference. He wrote a book on this. We have many, many talks about how to do the microservices. If you've not been to one of those before or not read the book, stick with it. You're going to be fine today. But I'm not going to spend 20 minutes explaining what a microservice is to you. We're going to jump in a little bit further ahead. So just as a refresher, this is what applications used to look like. You made code, it made squares. We called them monoliths. That's great. How many of you are the caretaker or custodian for a monolith? Yeah? How many of you are greenfield site and your application already looks like this in its entirety? These are the people to be jealous of. So everyone else in the room, go find those people and find out where the jobs are. because actually most of us end up building this first. It's actually a rare company that goes, you know what, MVP, great idea, let's put it out in the world, and I'm going to microservice from the start. The only people who do that are the people selling microservices as a consultancy or as an advisory service, or it's literally their business model. Most of us write something terrible in a language that probably wasn't designed for that purpose at 2 a.m. when we just had inspiration. That's how products exist. How many of you have code on the internet you aren't proud of, that is still in this state? Yeah, absolutely, we all do. That's the reality of software. But we're talking about moving from this monolith to these microservices, distributing it out. These are not new ideas. It's been going around for a very long time. Service-oriented architectures, way back in the day before we got so good with buzzwords, did some of the same stuff. Break it down, split it up, make it loosely coupled, and everything will work in a blissful utopia. We can go faster. We can spread things between teams. You know all of these things. I don't need to bore you with this. There are advantages, we know that. But what we don't often stand up on stage and do is go, actually, sometimes this sucks and it's hard. Actually, we can't always do all of these bits, and there's consequences to doing it. I'm not saying go back to monolith. But I'm saying, don't shout monorail and think it's the end of the world. Well, everything is changing. It is the bright new future. That's kind of feels like what we're doing with microservices these days. Now, I'm a security person. I've spent about 12 years doing bad things to computer systems. Lying, cheating, and stealing is basically what I do. But I now do that for defense. So I work with organizations to help protect from people like me, which is kind of nice. I've got some knowledge of how this is going to work. I care about 3 things. Now, in my industry, we're really bad with acronyms, and we decided CIA was a really trustworthy acronym for security. But either way, indulge me. This is about as textbook as you get for my talks. We care about confidentiality. So if I have a secret, I want to make sure only the people I've given permission to have that secret can get to it. Makes sense, right? Integrity. If I have a box, indulge me, I have bad analogies for everything. I've got a box. I'm going to put it on the table. I have an apple. I place the apple in the box. I do magic, and that's what my system's doing, magic. And out the other side, there should be an apple. It should still be in the same state that I'm expecting it to be in, because I control all of the magic in that box. If I put my apple into my box and a banana comes out the other side, and I'm like, what just happened here? We've probably got a problem. How many of you in finance, any financial systems-y people? How happy would your boss be if you put $1 million in and $2 million came out for no real logical reason? They'd be happy for 5 minutes, and then SOX happens. And then we all cry because Sarbanes-Oxley really doesn't like it when numbers magically mutate into new ones, even if they're good for our business. And availability. Let's not forget secure systems have got this bad reputation for being horrible, unusable piles of crap. If it's unusable, or you can't get to it, or it's slow in any way, it's not secure. So availability talks about us being available to our customers. We're not subject to denial of service, those kind of attacks. In fact, anyone who's done any threat modeling before will recognize this. This is Stride. This is Microsoft's open source threat assessment modeling kind of language. I recommend you go and read their stuff. For Microsoft stuff, it's actually kind of accessible and good for humans. So that's a good change. Stride tells us the types of attacks we're going to be subject to, because the world is a horrible, twisted place and people want your stuff. We're going to do spoofing and tampering. We're going to disclose information. We're going to try and find all of your deep, dark secrets by the easiest way possible. And in a world of microservices where we split things up and we've changed the way we're thinking about our applications, it's actually a different way for us to think about this kind of risk. We can't just apply this to an entire system anymore. We have to do it to something that's distributed. So let's talk about protection. First things first. Going to go through a couple of basics, but I'm going to send you out to some other sources of information because there's a few caveats. If you're a developer and you've not heard of OWASP, for example, there's some basics you might want to just go and read about. It's not my job today. If you sat through Troy Hunt, you will have started to get some of the feelings of the things you should probably already know. Scott Hanselman, in his first talk on the first day in his keynote, showed Stack Overflow posts. And I love Stack Overflow. I deal with people in 12 different languages most months. And I can see in code where Stack Overflow has gotten involved, because suddenly the coding style shifts, or suddenly magic happens, and suddenly a Node developer who's Node every day is suddenly writing Python in a very strange way. In microservice space, the advice going out is the same as wider application. There is no like special microservice version of application security. Some of the flaws still exist. If your place for going for security guidance is currently Stack Overflow, I feel bad for you. So this is literally pulled from Stack Overflow in the last, I think it was about 4 or 5 weeks ago. The gist is, somebody had asked, how do I store my passwords? Fantastic, great, awesome. There's quite steady, sane guidance for doing this. It's been around a while. In fact, the guidance evolves over time. And yet, the big green tick answer still remains MD5 with assault. Now, if you don't know why that's significant, again, go and have a think. MD5 is no longer considered anywhere near suitable for passwords. And it's the subtlety of this that I like, that this is what scares me. Because it doesn't look like an obvious troll. It doesn't look like an obvious mistake. It's not somebody going, oh, rot13 them or just store them in plain text because no one's going to see them. That looks like somebody thought about it. That looks like an engineer wrote it. And that's scary. So watch where you're getting your guidance from. So first link you should go and go to, if you're not familiar with OWASP, that's OK. I'm not going to judge you publicly. Please go and check out their stuff. They have a lot of things here, OWASP Top 10, but they have cheat sheets like this one. And the REST security cheat sheet is actually a really good place to start when you're thinking about API-driven development or microservices or anything in this field. The next thing I'm going to ask you to do is start minding your language, because as you start to see when we start getting into some of the specifics of the architecture, we're really bad at language. My 2 least favorite words in the entire universe are authentication and authorization. And as a community, as engineers, not just security people, we abbreviate these to exactly the same thing and use them in the same document next to each other. So for the purposes of this talk, and so that I don't confuse anyone who's not used to separating these terms out, I'm going to talk about authentication and authorization separately. So authentication, you're allowed in the door. Authorization, what you can do when you get there. If you work in an environment where they throw these kind of terms around loosely all the time, or acronyms, I do want you to start calling out the absolute tripe that's going on around you. Because this is dangerous. When we start assuming we know what language means, we get into real security problems. So let's talk about our architectures. Now, I do my designs and my slides in a very simple way. I don't need to show you 6 lines of Flask in Python to go, look, I did a microservice. Let's imagine each square is one of our services. I've used color in this and little letters on them. I apologize for the white on the green. It looks less horrible on a screen. Each of these services has different attributes. Let's talk about authentication and authorization for a minute, particularly authentication. So in this example, we've got our white bit in the middle. So normally there is something in the middle of every system that is where the real business happens, right? If you're in a financial processing system, there's going to be some batch craziness in the back end written in some awful language from like millions of years ago. And that lives somewhere in the middle. Around the edges and pulling out, you're going to have different services for different things, and they're going to have different needs when it comes to authentication. So we've got A for authenticator, just standard authentication. So we're talking usernames and passwords. We're talking about a certificate, perhaps, if you're not a username and password kind of place, or a key if you're doing systems to systems. We've got U's on the greens, unauthenticated. We don't need to authenticate people to use this. There's a lot of use cases for services that you don't have to authenticate against. I don't believe we need a world with more passwords. I think that's been going badly wrong for 15 years. So we've got 2FA, we've got unauthenticated and authenticated. And across your architecture, step 1 of protecting it is starting to map it out like this and start mapping the authentication requirements to each bit. It's OK to have different requirements in different bits. You don't have to leverage the same stuff across the place. There's a cost and a benefit to making these choices. The trick is to be consistent and plan it. And one of the problems with microservice architectures is you devolve them over teams. So I have customers who have 180 developers and they have 300 microservices because they're full on microservice happy. We've gone deep with this one. But the trouble is, those teams, actually, there's no central architectural point in that organization. There is no person who says, well, okay, team number 7, you're good to go, you go make another one, and we're going to add it, and here's your consistent piece from the middle, and here's our guidance as a whole. The teams are autonomous. How many of you like being autonomous in your work, choosing what you do and how you implement it? I'm hoping some of you, because if not, get a production line job. Because that's what coding becomes when you have no autonomy. It's add button 3 to page 2, click commit. Nobody wants that job. But if you're going to be autonomous, we've got to figure out a way to be consistent. We've got to articulate things like our authentication. One of the biggest flaws I see in these kind of things is getting it inconsistent and not understanding what you've got where. Visibility is hard in microservices, especially when you have a lot of them. Now, you've got 3 microservices for your little demo, yeah, you're good. You can see all the code on 2 screens. If you've got 300, that's hard. Authorization. So we decided how we can get in, but what on earth can we do when we get there? You don't want to be able to pivot through your services as an attacker, moving from an untrusted service, a simple one to get into, through to the trusted ones by a byproduct of how you're trusting the services together. That's how an attacker works. They will take a network of connected things, whether host on a network or services or people. People work just as well. And they will hop between them, trying to get towards something more interesting, more valuable. Our authorization has to be considered across the whole piece, and that's not just as a service, because a service, let's face it, we have some variable definitions of what a microservice is. I'm going to come back to that when we talk about service decomposition. It has to be per object, it has to be per endpoint and per method. So that's a lot more visibility over authorization and authentication we are used to. You do not want to get to a point where, by virtue of the fact that your users are on multiple devices at once, or it's a legitimate use case that you can be in multiple places at once, that cached information or strange access routes can give you more information than others. I will give you an example. LinkedIn. How many of you are on that cesspool of employment nonsense? Yep, we all are. None of us actually have a shared understanding of why we're there. We just kind of weirdly nod at each other across the room and go like occasionally when someone goes bacon. Right, why am I mentioning LinkedIn? Well, it's not a security flaw, so please don't take this as LinkedIn has problems. I'm not dropping 0 day. For a very long while, they had a mobile app and a mobile experience, and they had the online experience. Now, their business model revolves around getting people to pay for the upgraded experience. So you can see who's stalking you today, and you can stalk people more efficiently. In their mobile app, for a very, very long time, you could see a lot more information in the free version than you could in their static website. And it was by virtue of the permissions they had on those services and those endpoints were much more generous in the mobile space than they were in the desktop space. Now, from a security point of view, is this a problem? Well, maybe. It really was good for stalking people. But from a business model point of view, and let's face it, business model equals profit equals you still have a job at the end of the week. That's a problem, because suddenly their user base is going, I'm not giving you $100 a year, I'm just going to go use the mobile app. Protecting your business model is actually a security concern. Authentication in microservice architectures in any distributed does tend to start boiling down to tokens. We're passing tokens or certificates or strings around with us. It's very, very rare that we're passing usernames and passwords. In fact, if you know of an architecture that is passing usernames and passwords all the way around through it, stop. Completely, just don't ever do that, please, ever. And the same rules apply with these tokens as any other token in our system. This is where microservice people get horribly disappointed that I'm about to tell you things that are just normal web application security. Your tokens should be high quality. You should store them somewhere sensible. You should have them of a good length so that you can't brute force them, generate all of the permutations over time and guess, because that token is valuable. Now, I like to give mobile devices as an example of why we have to think about this consciously. Any mobile devs in the room other than Nigel? Okay. What's the big difference between the storage on Android and the storage on iPhone when it comes to storing tokens and things? What are the 2 distinct things you've got to worry about? Encryption. Local storage doesn't work the same between mobile devices, between versions of mobile devices if you're unlucky enough to have been playing in the Android space. where you're choosing to store your tokens, whether it's in local storage or encrypted storage, whether your application does some form of authentication and therefore you can get to the encrypted storage, all of these things matter. If you've got one part of your architecture or one endpoint where you can go and just lift a token up, that's what I'm going to do. I'm not going to go after the hard target where it's somewhere in the depths of an encrypted system. I'm going to go for the plain text version you've got compiled into a god-awful Flash application. And don't kid me, I know the world still revolves around god-awful Flash applications because I do threat assessments on them. Right. More basics. Input validation. How many of you know you're supposed to do input validation? Yes, good. How many of you feel you're good at this? Yeah? Okay, it's getting better. The frameworks are getting better. They're helping us. In fact, they're helping us to a point where we've forgotten we need to do it sometimes, and the framework's going to do it's fine. We have to be very careful in validating in microservices because we're doing a lot more data exchange. It's not the case of the data comes in from an untrusted source into our big monolith from the user in, and it's gone through one trust boundary. We've come into our application, but we're now going between many different trust areas. That data is flowing a lot more freely. Input validation doesn't need to happen just from when the user or another system outside your control comes in, but between components themselves. You have to assume any component in your architecture could be compromised, and therefore their input should be treated as untrusted. And most of us don't do that because that's a lot of work. We're taking a burden of validation in a tiny component, and we don't want that. So building up good shared libraries for this kind of thing and standard approaches, decorators, interceptors, whatever your language calls them is really, really crucial. So you don't have to reinvent this for every time. And I'll come back to this with the services now. Let's talk about this service decomposition. Because it's all very well me saying input validation is important. We've been saying that as a community for 15 years and we still suck at it. This bit's new, however. Service decomposition is not a skill that most developers innately have. If you do, if you're just gloriously gifted at this, I am envious. Because service decomposition is really hard. Turning a big jumbled mess of joyful code into tiny little things that work with a single responsibility, for example, isn't intuitive. A lot of us, because of that engineering brain we have that temptation to over-engineer everything we ever build, so it always grows a little bit at a time. We squish things together because we want to make it generic or shared or reusable, and all of this complicates things. And this is what we do. A lot of our organizations split naively, don't review, and then end up with this kind of propagation of slightly strange, naive services. Now, again, if you're one of these glorious people who, you write the books on microservices and you're good at this, great. But I deal in humans. I deal in real developers with real code bases that really are full of dragons. I'll give you an example. Naive dissection, naive decomposition into microservices leads to some really funny things if we go back to our authentication problem. Now, real-world example where we've seen services that have been split from a big, really kind of old, crusty data set. It's really nice because we were able to split these functions out, and in fact, we've used different languages for different things, and it's really nice. One of the things we did in this example, not we, I mean a client, but I get sued to hell and back if I mention client names, so you can say we, it's easier. Two of our services have started to use JWT because they're using more mature frameworks. They have JWT available to them. It's good. Good token system. What's that? What's that little green one at the bottom? Base64. Yeah, you can. There's Easter eggs in my slides. So if you ever see Base64, I do recommend you go and figure out what it says. But, for the people who just went to, I'm going to Google Base64 decoder. If you've got one service that is using an old technology and can't use the modern frameworks, or was split off early and you perhaps hadn't matured your approach to things like authentication, you can end up with a fragmented authentication space where one service particularly is getting a little bit crusty. It's kind of rotting in the background a little bit. And we don't always have the luxury of going back to all of our services equally after we, change an approach and applying it through. Now, we'll come back to this in terms of orchestration layers and how this can help. But in a world where you have just purely split it, you've got a chance that one or two of your services, those older services where you didn't know what you were doing so well, are going to cause you trouble later. And you have to be very conscious about going back to look at them. I know the reality of my code base is it's very rare that you get to go back and look at your oldest code, especially if it's not breaking and causing someone else pain. Security is never the reason you're going to get to go back to that middle bit. Size and complexity does really vary in microservices. Now, in the beautiful, blissful paradise, you go do your Flask example in the Python world, and it's 5 lines of code. You go into your browser, you open it up, hello world, job done. Fantastic. You write 14,000 lines of Node, and you get about the same result. I've seen a lot of microservices that I'm calling more macro services or mono microservices, where we've taken monoliths and just hunked massive chunks of them out. Or we've got lots of teeny tiny microservices around the edge for new things, and in the middle is the kludgy big monolith. You've just created an API wrapper around it. And is this familiar to anyone? Anyone writing software like that? This is how the banking world works, fundamentally. The trouble we have with this is when they are not equally sized, they are very different to protect. A big, clunky, not quite a microservice is very, very different to a very slimline one. And when we modify our approaches to have this uniform, everything's microservice now, we might oversimplify for those bits of our architecture that aren't like that at all. And those are the bits of the code that we tend to have a lot of fragility in. Service dependency, especially if we have one of these older legacy things in the middle of a microservice architecture, gets really messy. Because you can't, in many of these systems, take a piece out without other pieces hurting. And that actually breaks one of the principles that we try and embrace in microservices, right? We want them to be loosely coupled and not reliant on each other. But the reality is, if we have this legacy, if we're not green fields, this isn't going to work that well straight out of the box. There's going to be bits that you cannot help but fail around. And choosing how you're going to fail if that bit fails is going to be interesting. How is your app going to behave? How is it going to tell your user what's going on? Does it need to tell your user? What happens if something that is just a one-off, a batch processing type of job over in this weird service, if that fails, how does that cascade through your system? If one of your endpoints is subject to denial of service, not because somebody loves you particularly, but maybe your hosting provider is having a bad day, or a number of reasons why that service particularly is having a bit of trouble. How does that affect the wider architecture? Scaling is also slightly troublesome. Well, actually, it's easier than it's ever been in existence, which makes it troublesome by default. Because now we just tick a box that goes auto-scale. Fabulous, great. Yay! What does that even mean? For us security people, we hate magic. Just generally, it terrifies us. Wherever somebody says, oh no, the scaling thing's just going to take care of that for us, we worry. Most of the time, scaling is okay because it's just going to stand up exactly the same instance, just in multiple endpoints. But you have to understand what that does to your attack surface. Did you just go from one endpoint that was relatively easy to control to many? Which bits of your platform as a service are actually going to help or hinder you at this point? And how can you keep track of what you actually look like out on the internet? That's really important if somebody compromises your microservice architecture, or in fact, your platform as a service. Because a beautiful thing you can do as an attacker, and I have a strange idea of beautiful, I do apologize. Auto-scaling means auto-scaling of all things. So if I compromise your AWS account through your web application, because that's a thing, and I want to mine bitcoins, because I like shiny things, and bitcoins lead to shiny things. If you're auto-scaling, do you think this works in my favor as an attacker? Because I can tell you it does. I can just set it up once, and you scale it for me. I like this. You probably won't as a business. Probably worth looking at. How do you know if you've scaled for the right reasons? Is there a security reason that you've scaled that you probably need to be caring about? And do you have enough awareness and alerting in your environment to spot that? Some of you are sat there going, it's okay, we bought Apogee, or level 7, or whatever orchestration layer you've decided is the one of choice today. There are many, they are all equal in all of this, so please don't take this as a slur on any one in particular, but as an entire category of software. I am also scared by things that stand between things. One to rule them all scares me. As a security person, as an attacker, and as a defender, it's scary. As an attacker, I'm very lazy. You might have 300 different services doing different things. That's great and all. I don't want to have to figure out what each one of them does and what every endpoint is and where your external integration points are. I won't bother doing that at all if you have one of these, because this is the central brain of the operation, right? For most of it, it's directing traffic, it's doing your routing. It might even do some nasty DNS jiggery-pokery if you've gotten the right one. In those, we have hooks into different bits of the system. And in fact, most of these end up hooked into quite core systems, and I'll show you on a diagram very briefly in a bit. They scare me because they are really well marketed. This is a literal quote from one of their websites. You can protect your APIs from OWASP top 10 threats. Great, fantastic, we've got the right words. Such as SQL injection, XSS, and application DDoS. Absolutely, distributed denial of service. I don't want this. Like, salespeople around the world are like rubbing their hands in glee at the money that will roll in. And adaptive threats such as bad bots. I've been doing this 12 years and I have no idea what a bad bot is. I've got images of actual robots. Like, I really don't like you today. I'm going to shoot you with the pew-pew lasers. This is marketing material. This is a thing. We can't vouch for this just off the bat. We have to be able to hold those central components, orchestration layers, to a very high standard because we are trusting them with a lot of our heavy lifting. We've got our authentication tapped into it. If you're using single sign-on or SAML or any of that kind of nonsense, it tends to hook into these places. We are attackers. You are very lazy too. I say we a lot as an attacker, but I do actually mean every single one of you because you can cause as much bedlam in your company as everyone else in the world. I want you to reevaluate, look at your permissions, look at your life and see what damage you can cause. If you get really bored, say next week sometime, sit at your desk and go, right, I've got 20 minutes and only do this in theory because crime is illegal, but plan what you would do to cause a ruckus in your nice, shiny architecture. Because I bet you can come up with some really amazing things, because you know where it all lives, you know where the skeletons are. And if you can do that, you can start to plan your attacks, and you'll find the simplest way to do it. So there are features in orchestration layers that really, really scare me, and I'm not easily scared. I literally live in dark places. If you see any of these features, these are the things I want you to start thinking about. And I'm not saying don't use an orchestration layer. Please use one. They're a good idea, but do it consciously. And let's talk about these one by one. So impersonation. I work for vendor number 3, and I have an orchestration layer product that is in your network, providing things for all of your services. Great, fantastic. You raise a support query with me, and I'm trying to figure out what the hell just went wrong and try and get you back up and running. This is a pretty standard play, right? Managed service is a thing. Support contracts are a thing. If I, as a vendor, can impersonate you as a systems administrator and play around pretending to be you, this should scare you. You should never have an account or a facility in one of these tools where I can impersonate someone who has production administration access, because we break one of our rules. We break the idea of non-repudiation, which was up on that strategy list earlier. The idea that every action in our system has to be able to be linked to an individual, to a human. If we can't link it to whether it's actually Nigel or if it's someone pretending to be Nigel, we can't investigate when something goes wrong, and that's dangerous. You'd actually fail a lot of compliance checks for a start, but it's dangerous for many reasons. Investigation mode is the same thing. How many of you work on a data set that has actual human details in it, like people information? Most of us, that's, we're people writing systems for people, that's what we do. How many of you have ever Googled for yourself or looked for yourself in a data set or for someone you know? I know I have. That's what we do. We're also very curious. As a species, we are ridiculously bad at security just by default. We're not wired for this. If you have any kind of mode in this thing where you can just interrogate anything on the fly or see any session live, great power, great responsibility. Please be careful with these things. It's a breach of privacy for most cases, and sometimes it's going to screw up your compliance, and others, you can see a lot from this. And as an attacker, if I can see this, I can learn a lot about your environment. Demo accounts on production. This isn't new to microservices. You should be spotting some themes here. Raise your hand if you know of a demo account or a backdoor access to a production server anywhere in the world. Yep. 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 And those are the ones with the really bad passwords, for the record. Those are the ones that you set the password to 10 years ago and haven't changed because, yeah, it's fine. SSL interception and analysis. There's a lot of deep packet inspection being touted around. We can tell you intelligently what the deep runnings of your application is, and to do that, we're stripping the SSL off. We're putting it all back together at the end after doing some magic in the middle. That's very powerful technology, and you can do a lot of good protective things with it, but it's also incredibly, incredibly dangerous. If poorly configured, it's going to leave your data exposed, and you really want to be careful of that. You also want to be careful, are they sending that data off anywhere else? Because if it's a hosted one, so it's out in the cloud, it's not in your environment, there's a very good chance there are multiple customers using this service. That's how business works. And you want to make sure they're not taking stats, they're not taking any kind of aggregated or anonymized data from this SSL interception, because there's a lot in there. And even if they're doing it for the right reasons, it's good intention, it's probably going to go horribly, horribly wrong. If your orchestration layer doesn't allow you to have two-factor authentication, it should no longer be your orchestration layer. I'm just going to say that. Now, that two-factor could be you need to be on the right IP and have a certificate. It could be a little whizzy app on your phone. NIST, the National Institute of Standards and Technology in the US, has now said that two-factor via SMS is no longer considered secure, so please bear that in mind. You know, these technology and the guidance is changing. If you aren't doing two-factor on anything production or anything orchestration, please rethink your life choices. So how are we going to do this? Well, we're going to learn to choose some right technologies. We're going to restrict access to them, monitor them aggressively, configure them well, change assumptions, and test regularly. None of this is Microservice specific. Please apply this to every part of your entire existence. And I'm going to give you a few things you should go and do and use to help with this, particularly with choosing the right technology, because this all falls over if we choose the wrong one to begin with. There are golden rules that nobody ever talks about. Everyone sees a security company and they assume that the security company must really know how to do secure development. Turns out, as an industry, we're worse than you lot. I will openly, hold my hands up. I am as bad as everyone else. And it makes us quite arrogant. Things like this happen. These are the same, anyone who was in my talk the other day. Same slide, different reason. Look, this is Travis. Travis works for Project Zero at Google. He's a menace to all sorts of software. And this day, he was particularly interested in semantic. He tends to just go on whims, and you never really know what he's going to destroy next. Symantec have been having critical vulnerability after critical vulnerability in their system. This one particularly is really interesting. If you get a chance to go and look at Travis's feed and his bug reports and things he discloses and Project Zero stuff, they've got flaws in their software that has been bad practice since 2005, that their frameworks and languages already have built-in functions for, they're just not using them. This includes remote code execution, so somebody else running their own garbage on your servers. Escalation of privilege, so coming in as a normal person and making yourself God. And this is Symantec. So we've got this kind of preconceived bias that we see certain names and we go, well, it's that company and therefore we should trust it. Please, I do ask you, hold your security vendors to as high a standard as you hold yourself. If that standard isn't very high, work on that. And just because when you get these tweets, they're all in a row for him. And just in the middle, just this glorious thing, if any of you have the Fitbit scales, anyone got those? They talk to your wireless and tell you that you've had a bad day in at cake. There is a remote code execution on Fitbit scales. So if you've never patched Internet of Things devices, it does end very well. There's some socks that can compromise your network now and some bathroom scales. So welcome to the future. Please be a part of the solution, not the problem. OK, so here's two things I want you to go and look at for this section. Firstly, get used to this website. This is NIST, National Institute of Standards and Technology. They govern the CVs, the details of where vulnerabilities live. So whenever you're choosing a technology, I want you to go and look it up. Now, I will apologize in advance for my entire community. We suck at web design. This is like 1997 glorious standard of web design. But it's useful because when you're picking a tool, you need to have something to look at. How many times have they had a vulnerability in the last 12 months? Has that vulnerability been resolved? How serious was it? How quickly did they resolve it from the time it was published through to the time it was put there. There's a lot you can get just from looking at this, and it's open. It's public data. There's no dodginess here. This is the government of the USA. They tend to not do bad things to you too often. The second one is this one. This is from Google. Again, open source, completely open source. The code is there. You can go fork it, download it, do what you like with it. Don't judge it. It's not in languages that .NET people tend to speak very often. It's the Vendor Security Assessment Questionnaire. Now, it is 4 sets of questionnaires, but you can write your own custom questionnaires, and you can host it on your own infrastructure, or you can host it out in the cloud, wherever you like, and you can send it through to vendors. So as part of that choosing a vendor process, you have a right to ask them questions about their security. And this gives you a structure to ask them all sorts of things about their policies for things. Do they have an instant response plan? If their server center went up in a ball of flames, what's their backup plan? Now, they're not going to give you like the world of details here, but you'll get a feel for what they're saying and if there's enough depth or if they're even answering it. If the vendor refuses to answer security questions or just sends you to a salesperson, go try another vendor. We live in a place where actually there's a lot of competition here. So go have a play with the Google Vendor Security Assessment Questionnaire. There is a live hosted version. You can go and play around with it. There are some quirks with it. It is limited. You know, anything that is made generic and open source and public is not going to fit every case for you, but you're engineers. And the best thing about this is open source. So instead of crying, we could just fork it and make it work for us. So let's talk about identity and access management, because that's important too. This is one of the oldest principles we've been trying to teach as a security community for 15 years. We are not good at teaching. The idea that you should only have enough permission to do the job you do at that time. Now, that doesn't just go for human actors in your system, so like yourself, making sure that you don't have access to systems you don't need, but also all of the system components. So Pokemon got in trouble for this recently, right? For them, the problem came from the scoping of their application, what they were asking for from the user, what data they accessed. When we talk about our system components, we tend to get in trouble with this in databases, where we give lots and lots of permissions or have one database account to rule them all and share it between all of our services, regardless of what they're doing. What I'm going to ask you to do is, as you decompose your services, decompose the roles across them. So there will be non-human roles, there will be daemons and services that are interacting. There will be third-party integration points that are going to be sending you data in, might be interacting with APIs and things you've exposed to them. You're going to have human actors. You're going to have technical human actors like yourself, where you're deploying code or changing code or using it. You're going to have administrators who will actually be helping your customers find love and support in the app. And then you've got users. And it's not as simple as having these 5 things laid out and going, yep, I've done a list. It's really about understanding at each point how much permission they need and how this needs to translate now down from their accounts to the accounts of the systems that it's integrating with, so databases, third-party services. Please, 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 if you work on a system that has gone down the road of fine-grained permissions instead of roles, please, please be the voice of reason in this. A lot of people go, it's okay, I'll just feature flag it or I'll permission flag. And you know, each account you can just like really fine-grain the permissions, and then you can do it per user, and it's great. And you end up with a glorious checkbox-based form where you can tick things, or a horrible database query if you didn't get as far as good forms. The problem with fine-grained permissions versus roles is it gets complex. I worked on a system 2 years ago where we went in to have a look and had looked at their fine-grained permissions, and there were 987 distinct permissions that could be set per user. 987. The application was 10 years old. These things, they grow over time. Now, the problem with 987 distinct things is there are combinations. Now, I won't do the maths for you. You can go and do the maths of how many particular permutations there are of 987 different options. Because once you've got that many options and permutations, you can't rationally look at them all and see where the risk is. You can't even see it. We ended up visualizing this in D3, pulling the fine-grained permissions out of a database and visually displaying it as a graph with, you know, crazy Venn diagram meets graph, because that was the only way we could communicate what this actually looked like access-wise. If you can't communicate what access looks like, you can't protect things, because you can't say, well, this is the border of what is normal. This is what this should look like. Obviously, once you've got your roles in place, you have to audit it, not just because auditors are fun and happy people and you should have more in your life, but because you want to make sure that it's actually working as intended. That's pretty common sense, right? We'll come back to that in detection. How many of you are in the We've Gone Cloud? AWS, Azure, Google Cloud? A few? How many of you are still in the self-hosting? That's fine too. I don't judge. If you have opportunities to get into cloud environments, these platform as service things can help you out a bit here. And there's a few links I'm going to show you of things you can go and check out. Because we're about to move into our immutable architectures, and your platform as a service is going to help you with this. Your platform as a service has a lot more to lose than you do. If they screw up, they don't just lose one person, they lose all of their client base. And as a result, they have very well-equipped security teams. And I know a lot of them personally. They're very good people. So by using some of these, while the risk is there and your data might not live where you want, if you ever want to rant about data sovereignty with me, I accept cake. But your platform as a service is going to help you. They have, in AWS, for example, really mature role-based access controls and identity and access management. It's voodoo to configure. I'm going to be square with you. You're going to get this wrong the first 20 times you try and do it. But it's really powerful, and it can stop you having to do this yourself in the application. So if you're using a platform as a service, please go and investigate that. And let's talk about your architecture as a whole. We should be aware of immutable architectures by now. How many of you are like, yep, I know what that is? Who's feeling brave and wants to tell me? Docker, yeah. Or if you're not, and you're like, no, Docker, Vagrant or Ansible or Puppet or Chef. You could probably make a song now of the joyous words that are out there on the internet about this. The idea is that we do not have pet servers. We have, I don't like that analogy at all. But no special snowflakes. Everything is replaceable. You are just a cog in a giant machine, and nobody cares if you exist next day. Right. The beautiful thing about immutable architectures is it forces you to articulate your architecture in a way that can be coherently and repeatably assessed. Now, I do host reviews, or used to do host reviews, where somebody would give me a Linux shell and go at it, tell me if it's configured securely. That's not a fun process. That is not a repeatable process, and it's not one that you're going to be able to do all of the time. Immutable architectures, regardless of which hipster technology you've decided to do it with, will give you this option. I'll give you a couple of tools. You can go and actually do this for yourself. If you can audit it, you can check it over time. So if you're doing continuous integration, for example, you can do audits of this kind of thing in a continuous integration fashion over your architecture. So that if something changed in your configuration of your hosts, you are alerted in the same way as your code does. You can also do testing over it. I've got a team I work with do beautiful things with Ruby. Slightly dirty if you're used to being a Linux sysadmin, but they do all of their configuration rapid in Ruby, and all of their configuration infrastructure and architecture has unit tests. We have unit tests for infrastructure. How many of you do that already? Because if you do, that's awesome. Fantastic. That guy can tell you more about it. Most people don't. The ops side is completely foreign, so that they do not do testing. Testing is, I turn it on, it seems to work, and I can ping it on the right port. I know this. I looked after Linux servers. It was fun times. It also avoids configuration creep. One of the big scary things in this space is the propensity we have to change them quickly over time. And we introduce a lot of problems because of it. So if we can stop configuration creep, we can spot when something changes. Now, as an attacker, I'm going to get into your systems and I'm going to start changing things. I'm going to bring my tools with me because your tools suck and mine are better. And I've got an ego, and I like that. In some cases, we clean up previous attackers. So we will get into a host, find there is already malware there, and that malware is causing us trouble. So we'll clear that out for you, patch you, and then we'll set up base. And if you can see this, if your architectures are alerting on change, then you can prevent it. So the typical actions, there we go. That's what I want to do. Retaining access, installing tools, removing other actors, gathering pivot. Yay. Can't do it in immutable. Can't do it in Lambda either. So as an attack place, as offensive people, we struggle when you get this right. So please make us work for our money. Make it hard for me to stay around a long time. If I can stay in your systems for a long time, I will. It's cozy and warm, and I can get more stuff over time. If I can only get in, do something quick, and then have to get out, that's Still not ideal for you, but it's way better than the other options. So here's some things you should go look at, a little bit of homework. So if you've caught Docker, mushroom, you can go look at Docker Bench Security, which is a lovely, reusable script. You can audit your Docker containers, and it's open source. It's written by Docker themselves. They are lovely people. If you're AWS, you can use AWS Inspector, which checks for security flaws. I could do entire talks on these tools alone, but then you would die of brain overload. And if you like the Netflix cult of tooling, they have Security Monkey, which does similar things. Can audit a wider range of devices. Every tool I'm mentioning is either free to use or super, super cheap in AWS. I don't like big, expensive vendor things. So let's talk about a few things before we get into the detection. So first things first, how many of you write in more than one language every day? Yep. How do you like the idea that you can bring new languages in and try new technologies because it's fun? Yeah, most of us do, because we don't want to write Java forever. You don't want to write Java ever. You're in a .NET conference. That's like a really bad day. Trouble is, this is what we end up like. We end up like kids in a candy shop. And our microservice architectures, it's encouraged to use the right technology and the right service for the right job. So you don't get stuck in .NET land if this service over here would be better off in Erlang. Please don't do that. That's a really bad idea. But you get the point. You can, theoretically, choose whatever technology you like to serve the purpose of that service. The trouble is you need to make sure you're choosing the right language for each job. And that's not always clear. Because some people, like me, we do silly things like talk at conferences. And somewhere in the room, someone will go, you know what would be cool? I could do my project in this language, in this new technology, in this thing. And we get excited, and that's great. But we don't always choose the right language for the job. And not all languages are equal. I try to be quite equal opportunities in my slander of languages, but Node does fall foul of me many times. The newer languages have less maturity. Their teams have not figured out how to do things like checking the dependencies in their repos yet to check if they're actually sane and safe to use. So you need to compensate. If you're using newer technologies, don't stop using them. Just take a little bit more time when you're judging which libraries and frameworks to use and how you're going to protect them. I overuse this analogy, but I'll do it anyway. Every technology is a puppy. Every technology you bring into your infrastructure is a puppy. So if you've got many of them, that's great. They're adorable. You're going to want to play with them and do awesome things and tell your friends that you've got a new puppy and I've caught Node.js and it's great. But puppies poop on carpets. That's fine. You can handle this for one puppy. Everyone, you can get past it and make your way in the world. If your infrastructure looks like this, and what you thought was a Java shop is actually 12 languages, you've got a lot of poop, a real lot of poop. That's a lot of technologies to go monitor and watch, a lot of technologies to update and patch, and a lot of places to go and follow for good guidance. So please use this wisely. Just because you can, it doesn't mean you should. I'm not trying to spoil your fun, mostly. To reiterate some tools that you can go and help with this. So if you do open source, libraries.io is free. It's very, very cheap for paid. OWASP have the dependency checker, which will help you if you put it into your build pipeline. It integrates with Maven and Ant and Jenkins and whatnot. It will tell you when you do your build, you've got out-of-date dependencies that have security flaws, you should not continue. So that's a nice, easy way for you to do that. So just 10 minutes left, and we're just going to talk about detection. I literally talk for hours on detection, but this is just a flavor of what you need to think about with your microservices. Log all the things. Now, that's really easy to say when you've got one monolith and one log place, and they all end up in a nice, polite way, and it's all super simple, super simple. This does not work well or simply with microservices, especially if you've gone down the multiple puppies route of technology choices, because suddenly you've got a lot of different styles of logs and a lot of different types of data available to you. The important thing is where you keep your logs. Now, as an attacker, when you get into a system, often the thing I'm doing before I leave on the way out is I'm cleaning up the logs after me. I'm going to just flush those out, clean them down. If you're really lucky, I'm bad at that, and you can see there's a gap in the logs. If you're really unlucky and I have a bit of time, you won't know it's happened. It will just be moments that don't exist anymore. Make sure your logs are stored somewhere outside your architecture, somewhere secure, somewhere immutable you can't change, away from your production environments. Poorly managed logs are a security problem for two reasons. Firstly was this, I can go and ferret around in them and delete things. I can also learn a lot from your logs. How many of you do the silly log debug, send everything in my stack to the log when you're debugging? I do, from time to time. The guy is shaking his head, I like you, you've got style. I'm going to be honest, I do. My logs even say, giraffe, womble, what the hell just happened, and here's a stack trace. My logs aren't good, but I'm human. I'm all right with that. It's not just the normal day-to-day logs. There's all sorts of information that you aggregate in time over there. You can find your customer information, you can find technical information, and I can take out your architecture with a denial of service attack against a logging site. And here's how it works. Most architectures that put in centralized logging do it relatively naively. And a lot of people don't like using cloud-based logging solutions like Rayguns and what of the world, so they keep it inside their network. Those systems do not get the same love and attention as the rest of your shiny microservices people, because the ops people don't have as much budget. They just got told you were going to fire a whole lot of text files at them or log files and just go do your thing. So they might be using technologies that are a lot older than you're used to. It's very easy to denial service a network that is poorly implemented with its logging because you go after that point. You need to make sure that your architecture, your choices, will survive your logging system disappearing and tell you that it happened. Both parts of that are really important, so please be mindful. The other thing is, if you look at big famous hacks, if you want to read a really glorious hack attack, Phineas Fisher attacked hacking, oh my God, a hacking group out of Italy. And published a giant PDF of how he did it. Now, what was interesting, it wasn't application stuff he was attacking. He went after a Nagios server that was inside an architecture much like this, because the Nagios server was in the middle of all of this and trusted. Backup servers often have production root accesses built into them. Octopus deploy, I need Octopus users. And this goes for all deployment software. I'm not, Octopus are lovely, please, be nice to them. There is an ability in that tool to write custom scripting that will run with a permission level on a host. That you can do that. It's host level scripting is in there. Those are powerful tools, and as an attacker, if you can compromise one of those, you get all of that. So don't worry about each individual service. If you've got these components in there, give those some love too. And then watch your logs. Actually watching them. I know this bit is painful. If it is painful and you don't like watching logs because it's boring and nothing ever happens and you know that you've got a dashboard that nobody looks at because it was there to please some board members and to spend some budget, then don't make yourself watch logs. Make your security interrupt driven. So get good alerting. Set rules up, set regex up. I don't care what tools you use. You can look at my other talk and I'll give you some ideas as to what you can do here. But get it sending something that you can't ignore. If you live your entire life in Slack, it should be telling you very loudly with animated GIFs in Slack that everything is on fire. If you live in your inbox because you're in one of those painful sort of Outlook-y worlds, then having an email filtering system that sends everything to DevNull is probably not helpful. Make sure it's getting to the place you're going to see it. Doesn't matter where that place is. It's going to be individual for every single one of you, but you have to be able to see this, because if you're not watching, you've got a lot of moving parts, a hell of a lot now, and they're written in different technologies by different people over time, and some of them are older, and some of them are newer, and some of them are giant little white boxes that they look teeny tiny on the architecture diagram, but are giant monoliths that nobody can touch because dragons live there. And if you're not watching that, then you'll never see someone come in, and you'll never see what they get up to. And that's normally a really short path to not having a job at the end of it. So that's a bit of a rambling journey through microservice security. We've had a look at prevention. We've looked at some basics. We've looked at detection. I've given you some tools and some things you can go and read, because seriously, there's so much to cover. We could have spent a whole half-day workshop on this and still had more questions. If you have any questions, please do ask. But whether you are here and you just want to get to here, or whether you're here and you've no intention but you're curious, or whether you're here already and you want to avoid going backwards in time and ending creating monoliths because you got lazy or someone was rushing, please remember that security isn't just something for the end. And it's not just something for a team that sits outside of your place to come and think about. It's actually you lot are going to be the key to securing these. So please, little steps in all of your little tiny pieces, and hopefully we'll do something good. Any questions? Oh dear. shell shock. Oh, hello. Hi. Gentleman with a microphone is going to come and harass you.
So what's your opinion on using WAFs?
Web application firewalls. So the question is, what's my opinion on using web application firewalls? I like web application firewalls, theoretically. So a web application firewall sits in front of your application. It looks at all the traffic coming and going, and it says, well, that looks like this. It looks at the post requests and the get requests and whatnot. And it largely, like all security monitoring tools, is basically just regex with a pretty wrapper. That's great, sort of, but only if you tune it, only if you take it out of monitoring mode and you put it into enforcing mode and it's given some power to do something. What I tend to see is people spend $50,000 on a web application firewall, if they've got an enterprise. They put it in front of their architecture and they leave it in this monitoring mode where it's just generating alerts but not doing anything. At that point, it's not doing security. It's an expensive Cat5 cable, and you should probably not be doing that. If you're not in the position to turn it on and tune it back, and that does take time, a lot of time, and the right people, then it's not worth the spend. You'd be better spending your money on something else. Hi.
Any open source tools for security testing web APIs? Any open source tools? Like for web apps, you have Zap.
Mm-hmm. Okay, so the funny thing about security tooling is you don't need to use security tools. When I do my security testing of APIs, I actually tend to be using Postman a lot. I use the same dev tools I use to build them to break them. Other things that are really cool, there are some open sourcey kind of security testing frameworks out there. So BDD security, for example, and Gauntlet, and you can write the same kind of test harnesses you do for normal functional testing in APIs, but with a security feel to them, so they're testing for security things. So I would actually recommend, instead of looking for a new tool, re-angle the tools you're already using and just bring a focus to that, because new tools adds complexity to your life. You're already busy, so just kind of do it where you're already doing it. Also, you developers, your tooling is so much better than ours in every possible way. We just want to use it in a slightly more mischievous manner. Anything else? Well, I will be around shortly in the corridor if anyone wants to come say hi. That would be lovely. You've been lovely. I was here. We did a thing. Have fun.